All right, there we go. All right, welcome back to the last formal session for this afternoon. Our first speaker in this session is Bruce Fuda. Before we do, actually, should I mention, if anybody's got any lost property, there is a lost property, see the organisers at the front desk. They have had a few things that have arrived that are ownerless. There we go. Okay, our first speaker, Bruce Fuda, is currently the Associate Principal and Director of Technologies at Gungahlin College in the ACT. He is a member of the Advisory Group for the Development of the Australian Curriculum Technologies during the writing phase. He's also President of Information Technology Educators ACT. He was recently named by ISTE the 2016 Australian ICT Educator of the Year. Everyone please give a warm welcome to Mr. Bruce Fuda.
Thanks, Russell, and hopefully audio is good and everyone can hear me fine. So, thanks for coming along this afternoon. You could be in another more technical talk. I hope that what I'm about to show you is going to make you rethink the technical capabilities of students in high schools. And I hope that what you get out of it is of interest enough that you share it with everyone who's missed this talk and they catch it online, because this is really a call to action for the developer community, and I really want to make sure as many people as possible hear that. So, very, very briefly, a little bit more about me. I'm a teacher. I am also a developer, and I do a lot of work in the curriculum space and was lucky enough to be involved in the development of the digital technologies curriculum. I did a talk on Friday specifically on the educational context and where I've come from in terms of the adoption of Python at my school. And if you find this talk today interesting, I suggest that you go back and have a look at that. The introduction there really does emphasize some of the work that's happening in Australia around computer science and IT education. So it's definitely worth a look if it's something that you find interesting. So, before I begin talking about the student projects, I want to emphasize just a little bit the work that's gone into developing the teaching program that's allowed this to happen. And at Gungahlin College, we are senior secondary only. We only see students for 2 years. They come to us in year 11. They come from a number of different schools, and they've all had very, very different IT experiences at that point. So we'll have students who have never seen code before, and we'll have some who may have been writing programs, at least starting with maybe a visual programming language like Scratch from about year 3, year 4. So it's a very, very wide spectrum, very, very different capabilities for the students in the group. And in year 11, we start out by giving students some introductory courses on these 3 main sort of themes and streams in the school. We do some computer science, we introduce them to Booleans, the nature of logic, and the concept of a state machine. In our programming course, we introduce them to Python and we look at some of the language fundamentals, and in web design, the beginnings of design principles for the web and the basic technologies that underline that. In the second semester, we move into algorithms and data structures. We introduce some recursion. In the programming side of things, we introduce them to both object-oriented and event-driven programming paradigms. And for the students who are particularly interested in games programming, they can start to explore the specifics of that. And the web students are introduced to databases and some introductory Python at that stage if they haven't done the programming units. Then by first semester year 12, they're starting to look at things such as algorithmic efficiency, complexity. They're modeling complex data structures. We do some combinatorics. In programming, we're starting to look at the use of inheritance in meaningful contexts, as well as looking at some more advanced Python. And I say advanced, we're talking about things such as list comprehensions, how to use the sort of standard data structures in interesting ways, functions such as zip, that kind of thing, moving it a little bit further on from the basics. And you can see that in web design, we introduced the MVC pattern, and they use Flask as their sort of framework for building web apps. And the projects I'm about to show you kick in there. If you think of this as a continuum from the start of year 11 through to middle of year 12, it's actually quite late in that first semester where these projects begin. So, our first project, Prophecy. Prophecy is a text generation engine, a parity text generator, and a text prediction engine built on Python using Markov chains. And this is what it looks like. Now, I have to emphasize, these are student projects and they're students who have, as I said, come from very, very little background, so they're not necessarily very pretty. You can see it just fires up a little menu. You, in this case, set up or select that you want to parity generate some text, and it spits something out on the basis of the model that's in there. Now, the additional menu that I'm going to bring up in a second and that we'll look at will actually allow us to display the dictionary that's been used to generate that text. What you'll notice is that the dictionary is made up of single, two-word and three-word tuples that are then stored, and the likelihood of individual words following on from that is all already in. The text has come from Harry Potter novels and Twilight novels at this stage. Turns out it's very, very easy to get those as text files off the web. And then this is the text generation, text prediction engine in action. So you can see new words are entered, the highest, or the three options with the highest frequency are presented, because they learn very, very quickly that you can't just present the highest frequency each time, or you end up in a very, very small loop very, very quickly. And this just runs infinitely. So the idea being that if this was on your phone, you would use it until you finished whatever text it was that you were generating. So it's pretty cool. You can clear the dictionary at any stage. You can read in any text you like. It's quite literally just text files, and it will process the text that you feed it and store it in a hash table, a dictionary. So this is some of the code that the students have written. Fairly simple Markov selection function that they call as needed. These are solved problems, I get that, I know that, but not for these students, they're not, right? These are really interesting problems for them. And this is the parity generator. You can see the calls, the Markov selection functions they've written before, and the predictor, which on the basis of the words that it reads off the terminal that the person's just written in, then makes some suggestions. So what's really cool about this project is that it was written in 3 weeks. Okay, 3 weeks by 2 students. One of those students hadn't even been programming for 12 months at that point. It was the first time she'd learned programming was at about sort of July or August of the previous year, and she wrote this in April, May. The other student hadn't been doing any programming for a couple of years and had never seen Python, so the only programming experience he'd had was C#, and the two of them needed to manage their project between the two of them, and so they learnt Git on the way so that they could do some collaboration. And when the English teacher of one of the students got wind of this, he said, hey, when we're doing our postmodernist literature study, why don't you have a look at how computer-generated text could have an impact on how we see literature in the future. So she actually used the parity generator as a means of exploring postmodernist literature and what the implications might be as we see more computer-generated texts in the future. So that's pretty cool, right? The next one I'm going to give you a look at is Pathway. Pathway is a web-based tool that allows you to upload a custom user map, and it then scans the map, identifies all of the passable and impassable areas on the map, and uses A* to determine how you should get from one point to another. Okay, so this is it. It's not pretty. This is just a very quick map they threw together. You upload it. All of the orange circles there are passable nodes. All of the black is impassable. You enter the 2 nodes that you want to search to, and bang, it finds the most efficient path from the start point to the end using A*. You can change your inputs and outputs very, very easily. The one thing that they didn't get a chance to implement was a really nice interface for identifying exactly where in each of the open spaces might be the intended destination so that they could name them and do things like that. So you do have to know which node you're going to be able to map out the path. But this was the second iteration of a project they began previously where the nodes were known. So they wanted to move it beyond that and actually start looking at how you could take a custom map and turn that into something that you could then run some navigational tools on. So, as I said, built on Flask, this is the ray tracing algorithm they used with the image that was uploaded. So all of this was written by the students themselves, usually using some external modules, which I think was really cool. I did not tell them which modules to use. They would come to me with a project. Often I'd never implemented anything like this before, and I'd say, hey, yeah, let's go ahead, let's do this, right? The worst thing that can happen is you end up with an implementation that's incomplete. This one was a little over 4 weeks because, as I said, this was the second iteration. The first one was done on a static map. Now, the media, local media got wind of this, and as a result, the guys were interviewed, and a local business in Canberra that actually does indoor mapping contacted them, brought the two guys in, had a bit of a chat about the work they'd done, and offered one of them an internship. So that's pretty cool. Again, these are students who had only been programming for, in this case, 4 years, so a little bit more programming behind them, but we hadn't actually explicitly covered any of this material. I showed you before, we did some algorithmic efficiency, some basic combinatorics, but the rest is essentially their choice. So KSUM comes next, a text summarization tool. It's monolingual, and it uses TF-IDF and k-means clustering. So this student came to me with what I thought was a really interesting idea, and I said, yeah, sure, give it a go. It wasn't something that I'd had a student attempt previously, and what I'm doing here is just grabbing the URL to a Wikipedia page for the turquoise parrot, dropping it in at the prompt. Now this reads text entered at the prompt as well as a URL, so we did have to use URL loop to get this, and it extracts the most relevant terms or sentences from the article and publishes them on the screen. So there's quite a lot in there, and it extracts about 8 to 10 sentences in general. To show that this wasn't sort of a very it works in only very small contexts, I just grabbed another page at random when I was throwing this video together last night, grabbed the Tiger page, and again, a summary, quite a few fewer sentences on this particular article. Clearly, the cluster, the largest cluster was a little bit smaller. And what I thought was really cool about this is that the code was put together with a couple of different modules that he'd written himself that he then imported and made use of. The k-means clustering was all done, well, he did his own research for it, and then he made use of a lot of existing Python libraries to do a lot of the processing of that data, which was cool. And you can see here, he also does some of the parsing using Beautiful Soup and gives you the option of opening an external URL as well as inputting the text manually. So this student managed to do all of this again in about 3 weeks, and that was from initial concept to delivery of the product. The reason he chose to do this was because he's ESL. English was not his primary language, and the frustration that he's always had with articles that he's been given by teachers and that he's had to go to online to find additional information, there's a lot of additional info in there that he just doesn't need to understand the concept. So he figured this was a really great tool that would help others like him out. And as a result of the success that he had, he's currently working on an app that is going to allow visual translation of text from one language to another. So he's working with another student from the class on that right now. I'm not quite sure where they're at, but because I'm not teaching that unit at the moment. I'm still around the school and I do drop in and out every now and again, but at the moment they're just getting their heads around mobile development frameworks. So they haven't really started on the translation bit yet. This is one of my favorites. So students said, hey, I'm gonna do some machine learning. I wanna know how neural networks work. That's a massive ask because nobody knows how neural networks work. And as a result, he decided he was going to start with handwriting recognition. So this particular screen, when it's red, it means it's in training mode. Okay, so this particular application has already been trained on a very, very large data set. He spent quite a lot of time at home training it with his own dodgy writing on a touchpad on a laptop. Right? So this is my attempt at writing Python on a touchpad. Not particularly great, but I thought it was all right. And what you're about to see now is you type in, or you write what you want, you type in the intended message, it records that pattern, and it stores that pattern. Now, I didn't retrain the data with that because retraining takes a very, very, very long time, and you don't want to sit here staring at dots for ages. But when it's in green mode, it will do the it will actually attempt to recognize the letters. And you can see here the probability scores for each of the letters along the top. My writing's rubbish compared to his. It really doesn't line up. But when he demonstrated this with his writing and the stuff that he'd done, what we found is that the accuracy rate was pretty high. Letters like O and C or A, those were all kind of confusing. H and N would often get confused. But as a general rule, it did a pretty good job. So some of his code, this is the training code, right? So he was able to articulate to us very, very clearly during his presentation that basically he wanted to take all of the letters that were drawn, scale them into a 5x5 matrix, because that was the amount of data his computer could handle, and then store all of that and use that as the basis of doing the comparison. Right? So this is his neural network code. So you can see there that he's making use of NumPy to do a lot of the conversion, and he declares his sigmoid there. So this was a really, really ambitious task. I was really impressed with what he managed to do in 4 weeks. And that meant learning about neural networks from nothing, because that was not something that I'd covered in the course. So as a result of this, he became the expert in the classroom, the expert in the school. Actually, he's probably the expert in all of the Canberra schools at the moment, right? And as a result, when he presented this material to a panel that included myself, another teacher at the school, and 3 university lecturers, he was very, very confident in his presentation and was able to address the questions and queries that the panel had about aspects of this with quite a lot of confidence. And this all started because he's interested in machine learning and AI in games. And in fact, he's been playing around with writing a game that will have its rules determined on the basis of the machine learning, rather than actually defining the rules too early on itself. So he's going to have some platforms and some things like that, and he just wants to see what's going to happen. Do I think it's really going to work? No. Will it be an interesting problem for him? Yeah, right? So I'm not going to stop him. I think that's really cool. Spam away, a naive Bayesian classifier for dealing with spam, right? Solved problem, but an interesting one for a student who's trying to get their head around how this sort of stuff works. So spam away has both a training mode and a classification mode. This is the data that was received, so a classic spam email, a couple of emails that I sent him telling him that assignments are ready and that he needs to make sure he signs on for work experience. So definitely not spam, very, very important stuff. And then his other training file, which I think was basically a dump of every spam email he'd ever received, right? So lots and lots of rubbish spam. This is how it works. You launch it, you point to the email, which is just the text from the email, and then it determines whether or not it's likely to be spam or not. The kinds of questions he was asked were things like, how did you do your comparison? What sort of thresholds did you have, right? What amount of data was necessary for you to determine the classification? And through a number of iterations and changes to his code, he worked out that essentially the top 3 or 4 words, he only prints out the top 2, but the top 3 or 4 provided the best indicator as to whether or not it was likely to be spam based on his training data. Right? So he was able to tell us that quite confidently when he was presenting that to us. This is the training. So again, all Python. He uses ultimate spam as the basis of his training, but then you can train it with additional files that you add. This is the probability calculation of the likelihood of spam, and all of that sort of just fed very, very nicely into this very simple application that he built in, does anyone want to guess? Yeah, 3 weeks. Right? And again, no experience with these concepts, right? So it was just the need or the desire to learn more about AI that got him into this. And one of the things that was really cool about this one is he challenged the guys working on Prophecy to write a parody generator that could get past his naive Bayesian spam classifier. Okay, so it was really cool to see that collaboration across the 2 projects. That was not something I'd intended to happen, but it made sense, right? That's kind of one of the reasons that you might actually generate text using a Markov model to bypass spam filters, right? So that was a really, really cool, unintentional result of the work. This one's really cool because it's got some really wide cross-curriculum sort of stuff happening in it. So in our mechatronics class, we're launching a high-altitude balloon later this year. And last year, students who were in mechatronics worked with students in IT to launch a rocket. right? They built a little circuit and they launched it up in the air and they collected data, and they basically wanted to see whether or not, as a prototype, that was going to work for them. So the idea of this simulator is, you can see that little arrow there, that's the balloon in the direction it's facing. They're collecting or displaying all of this information that they're going to be able to extract from the sensors that they've already got on there. And they're trying to determine what kind of parameters they're going to need to be able to construct or build into the steering mechanisms of the balloon to be able to retain the payload once the thing launches. So it's an interesting problem. It's applicable to the work that they're doing, which I think is really cool. And one of the really interesting things about where they took this model is that they're not only sort of, I'll show you the configuration file actually. This is all the information that is configurable in the system, right? So they collect all of that. But one of the things that they want to make sure that they can do is that they can take into account the various wind conditions in the different layers of the atmosphere, right? So the work that they're doing at the moment is on integrating that particular model into the system so that they can have a look at what impact that may have on getting the thing back. So, as I said, really cool in terms of its sort of cross-faculty stuff. This was 4 weeks, including the physics behind it that they also had to learn. This is a really high visibility project as well. The local media is really flying with this. We've been in the paper a couple of times and we're getting a lot of attention, which is fantastic. And the idea is that the simulation will receive the data from the balloon when it's actually up there. Now, again, very ambitious, but I like what they're thinking, right? So this is the last bit, and that is why you should care about all of this. Okay, it's really cool that these kids are doing it, but I see the community, not just the Python community, but the developer community in general, as being a really important part of ensuring that these opportunities get extended to other students. So what you can do, and I think this is the most valuable thing that any of us can do, is be a positive and active role model, right? And the first step of that is to provide support. Not every school has a teacher like me with my experience and background. Very few of them actually have a lot of IT teachers because of the way that the curriculum has been structured prior to now. And as a result, the expertise is not there. But you guys have expertise. And one of the things you can look at is how you can potentially work with schools and support teachers and students so that you can overcome some of these shortcomings in terms of that expertise and skill. It'd be great to see more advocates for computer science and the digital technologies that are really vocal and out there in the community. Because the last thing we want is for this to sort of be filtered out or disappear, or for a lot of the advocates for it to not say anything and allow other advocacy groups to sort of take control of what the curriculum might look like in each jurisdiction. Encourage students in any way that you can. Look for outreach opportunities. The National Computer Science School is one, Young ICT Explorers is another. Get out there, get visible, and make sure that every time you see students doing cool things, you're giving them the thumbs up, because they're hearing from real developers that what they're doing is meaningful and cool. They're going to keep doing it. One of the things that really disappoints me as a high school teacher is that there are often awesome opportunities available to first year, second year, third year university students, but they don't extend to high school students. No one wants to deal with a 16-year-old on work experience who doesn't know anything. Well, these kids are 17, and it'd be awesome to get them working on little projects in various businesses and development groups and all that sort of stuff. So it would be awesome to see those opportunities extended to kids in high school. And be inspirational, right? If you share your successes in the wider community and they hear about them and they do something about them, they're going to be more likely to pick something up and run with it. And that's something that I think all of us want to do. They hear about all of the great things that are happening with, automated cars and things like that. Let's get word out about all of the projects that we're all working on. So that's it from me. I've got a little bit of time for questions. Thank you very much.
Thank you very much, Bruce. If you do have questions, just make your way up to the mic so we can get them out there while people work their way here. Are you looking for projects for people to be involved in? Have you considered approaching open source projects to contribute?
Open source is definitely one avenue that we've talked about. The challenge for students at that point is they're often overwhelmed by the code base. Often it's sort of already been put together. There's quite a lot in there. Not every project is very well documented. We've heard a little bit about that earlier in sessions today. So one of the things I think that would really help on that front is to see some really solid documentation and some people in each of the communities that can be a contact person almost for people who are new to the project.
My question's around motivation. So one of the problems that I've run into is, like, my kids have grown up with iPads, essentially. So they're kind of competing with those kind of projects which have a lot of time and effort and polish gone into them. So how do you overcome that sort of gap between their expectations and what they can, reasonably achieve?
It's a tricky one. We have that problem particularly in games development, where everyone wants to make the next Call of Duty, and they're a one-man development team. One of the things that I really emphasize with them is that if they can find out what it is about that product game thing that they find compelling, to then investigate that. And if you can somehow help them identify what that is and get them thinking about why it is that's compelling, then you can start finding other examples or projects that they'll also find compelling and help them identify that thing. And at that point, they start to realise that the polish probably, well, it's nice, it's not the primary motivator here, because it's very, very easy to get caught up on the polish and not see what's going on underneath. So it's about being really explicit about identifying that aspect and ensuring that they understand that's what they need to be looking for. Yeah.
Thanks for the talk. That was really great to see examples of kids doing that sort of thing. And one of the things I loved was seeing the ways that they learnt stuff like k-means clustering, neural networks, that sort of thing. And so I was curious what help you gave them to get along the right track to learn some of those topics or to find the tools in Python, or whether that was entirely self-motivated.
A lot of it with the higher performing students is independent. For the ones that are probably struggling a little bit more and need more assistance, I call on a lot of my developer friends. I say, look, kid wants to do this, where do I go? What should they be looking for? So that's a really valuable source of information for me. I think the key is to give them a really solid grounding in the fundamentals, and it's why we invested quite a bit of time in ensuring that at all stages of their learning, they're doing some computer science, they're looking at some fundamentals, and there are some guided activities that really emphasise that.
Hey, I'm desperately jealous of you, but I want to know, when you have a really cool project with a kid comes and says, I have this great idea, I want to investigate this thing that's interesting. When people do those kinds of projects, they have a high failure rate. And that's real. Like, doing interesting stuff is prone to failure. And they're young and they're inexperienced, and they have a mark that's associated with it. Like, how do you balance risk aversion and the interesting bit?
So one of the things that's different in the ACT, and Amanda's very well aware of this, is we don't have an external exam. So it doesn't actually matter if they do fail on this, because I can assess aspects of the process or the understanding of what's underlying what they're trying to produce as the primary mode of assessment. In a situation where you've got an external exam, it's a little bit different, because you have to make sure that they can perform on that. So when we think about how we're going to assess students, we really focus on ensuring that what they're being assessed on is the communication of ideas, their application of concepts, and the way that they've actually thought about how they've constructed their project, more so than what the final outcome can be. And that's why you'll see that we haven't required them to spend a lot of time on polish. That's unfortunately not an answer as such, other than to say, advocate for an environment that allows you to do more of that and less of sitting a standardized test where they don't even write code and are forced to do everything in pseudocode. New South Wales.
All right, so thank you again very much. Thank you very much, Bruce. Everyone, please give him a round of applause.